Okay, so I'll show you an alternative to prim just really quickly, which is called Kruskal's algorithm. And it's going to lead me into a discussion of cycle detection, which I'll talk about in another segment. But let me first just explain how it works because it's interesting comparison. So it's going to work by looking at all the edges rather than by looking at the nodes. And it's going to sort all the edges by increasing weight. And then you're going to go through the edges and pick the ones that don't create a cycle and ignore the ones that create a cycle. And it's very that simple. So what do I mean by that? Well, let's look at this graph, for example, an undirected weighted graph. And let's consider all the edges. So there's the edge DE, which is 1, the edge DG, which is 2. And so we sort by the edge weights of all the edges. So this is a complete representation of the edges. EG is 3, and so it doesn't really matter what order we put the ties in. And again, there's not a unique answer, but there's an optimal answer. And this will produce the optimal answer, even if it's not always going to produce the exact same one that prim produces, right? And so then we just loop through these one by one. And if a cycle is produced, and I'll show you graphically what a cycle looks like, then we'll talk about cycle detection using depth first searches. Let's take a look at it. So edge 1, that's obviously no problem. Edge 2, D to G, see, there's still no cycle, which means that there's no way that with these 3 nodes, I can return to any of the nodes that I start from by the edges that have been accepted so far. But if I were to accept EG, then I would obviously have a cycle, right? So starting at one of these nodes, I would I would be able to return to that node. So that's going to be no good, okay? But if I include CD, that's not going to create any cycles. That's fine. If I produce GH, if I accept GH, that's fine. There's still no cycle in the graph. CF, obviously you see this graphically, so we need a way to do cycle detection again, but I think this illustrates the high level point. So CF, that's fine, accept it. BC, I think this is a really cool algorithm. BC, does that create a problem? Yeah, that creates a, wait, B to C, no, because these are red. There's still no problem with B to C. B to E, B to, that creates a problem, right? It creates a problem because we can, let's see, it's a little hard to see the red. So if I go B to E, then I can go bump, 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 bump. So that's going to be no good. B to F, that's going to be no good. That's an obvious cycle. B to H, that's no good. I can get around back to B that way. A to H, that looks good. That does not create any problem at all. Fine. Now I'm done because I visited all the vertices, so I don't have to consider these, and I get the total cost of 21. Okay, so really neat algorithm based off of sorting of edges and cycle detection, and we'll talk about how to do that in a segment in the near future.